I'm sure by now we've all heard stories or some news article claiming that radio signals are coming from the galaxy. Well, today we just received a new article stating that mysterious flashes are coming from the center of the galaxy. Let's look at what they mean. As our eyes on the sky grow ever more sensitive, we're going to find more and more things that we've never seen before. Such is the case for a newly discovered source of radio signals located not far from the center of the galaxy. It's called ASKAP J173608.2-321635, and astronomers have been unable to figure out what kind of cosmic object best fits its weird properties. We have presented the discovery and characterization of ASKAP, the highly polarized variable radio source located near the galactic center and with no clear multi-wavelength counterpart. This was explained by a team of astronomers led by Ziteng Wang of the University of Sydney, Australia. This may represent part of the new class of objects being discovered through radio imaging surveys. This signal was discovered using an Australian Square Kilometre Array Pathfinder, or also known as ASKAP, one of the most sensitive radio telescopes ever built, designed to peer deep into the radio universe. It's already proven adept to finding things we have never seen before, such as odd radio circles, undiscovered galaxies, and mysterious fast radio bursts. This might turn out to be a known type of cosmic object, but if it does, it could end up to stretch the definition of whatever that object is. We've never seen anything like it, Wang says. It's highly variable, emitting radio waves for weeks at a time, and then disappearing on a rapid timescale. The signal is also highly polarized. That is, the orientation of the oscillation of the electromagnetic waves is twisted, both linearly and circularly. The object, whatever it is, had not been seen before the ASKAP detections made during a pilot survey of the sky to look for transient radio sources. Between April 2019 and August 2020, the signals appeared in the data 13 times. Follow-up observations in April and July of 2020 using different radio telescope Mirang in the Parkes, Australia, yielded nothing, but the Meerkat radio telescope in South Africa got a hit in February 2021. The Australia Telescope Compact Array, ATCA, also made a detection in April 2021. This supports and validates the ASKAP detections, but also suggests that the source is quite elusive. There were no Meerkat or ATCA detections prior to that date, nor did the source appear in an X-ray or near-infrared observations, nor in the archives of radio data collected by multiple instruments that the researchers checked. This leaves for a very fascinating mystery. The polarization suggests scattering and magnetization, possible partially due to the dust and magnetization fields in the interstellar medium between us and the source. All up, it's really hard to figure out what the source might be. There are several types of stars that are known to vary in radio wavelengths, such as stars that flare frequently, or close binaries with active chromospheres, or that ellipse each other. The non-detection in X-ray and near-infrared wavelengths makes this unlikely though. Flaring stars usually have X-ray emission that corresponds to the radio emission, and the vast majority of stars have ratio near-infrared emission that should be detectable. A type of neutron star, called a pulsar, is also not likely, with sweeping beams of radio light, like a cosmic lighthouse. Pulsars have regular periodicity on a timescale of hours, and ASKAP was detecting fading, which is inconsistent with pulsars. Also, there was a 3-month span with no detection, which is also inconsistent with pulsars. X-ray binaries, gamma ray bursts, and supernova were also ruled out. However, the object does share some properties with a type of mysterious signal spotted near the galactic center. These are known as galactic center radio transients, 3 of which were identified in the 2000s, and more of which are awaiting confirmation. These sources are also yet to be explained, but they have several features in common with ASKAP. If the two are similar, detection could help us find more sources that are similar and figure out what they are. Given that the signal is typically not detected and can turn off on timescales of several weeks to as quickly as a day, our sparse sampling suggests that there could be similar sources in these fields. Increasing the survey cadence and comparing the results of this search to other regions will help us understand how truly unique this is, and whether it is related to the galactic plane, which should ultimately help us deduce its nature. More research and results in regions can help us understand how truly unique this is. What do you think these radio signals could be? If you like this content and would like to see more of it, leave a like and subscribe for more content like this. Thank you and stay safe.